The 737 ice and rain protection systems keep critical areas of the airplane clear of ice and rain. The bleed air directly from the engine heats the engine cowls. The bleed air from the pneumatic manifold heats the leading edge slats. The flight deck windows and all probes are electrically heated to prevent ice formation. The windshield wipers maintain clear areas on the windshield during takeoff, approach, and landing. Icing conditions exist in flight when the total air temperature is 10 degrees Celsius or below, and visible moisture is present. Visible moisture is rain, snow, sleet, ice crystals, or clouds and fog with less than 1 mile visibility. Icing conditions exist on the ground when the outside air temperature is 10 degrees Celsius or below, and you are operating on ramps, taxiways, or runways when there is surface snow, ice, standing water, or slush. You control engine anti-ice from the flight deck by engine anti-ice switches on the forward overhead panel. The switches have on and off positions. The on position opens the engine cowl anti-ice valve, and engine bleed air goes to the cowl lip. Turn on engine number 1 anti-ice and look at the cowl valve open light. The cowl valve open light shows the position of the engine cowl anti-ice valve. The light is extinguished when the valve is closed. The light is bright when the valve is in transit or there is a disagreement between the valve and switch position. The light is dim when the valve is open. Turn on engine number 2 anti-ice. Look at the engine cowl anti-ice valve and the cowl valve open light. The engine anti-ice must be on during all ground and flight operations when icing conditions exist or are expected. Do not rely on visual cues before you turn on engine anti-ice. Use the temperature and visible moisture criteria. When engine anti-ice is required, first turn the engine start switches to continuous. Next, turn on the engine anti-ice. Make sure the cowl valve open lights illuminate bright, then dim. When the cowl anti-ice valve is open, a thermal anti-ice indication is shown on the engine display. When the engine anti-ice is no longer necessary, turn off the engine anti-ice. Make sure the cowl valve open lights extinguish. Finally, turn off the engine start switches. Caution: do not operate engine or wing anti-ice when the total air temperature is above 10 degrees Celsius. Let's now look at some non-normal conditions with the number 2 engine. If the cowl valve open light remains illuminated bright when the engine anti-ice is turned on, the valve has remained in the closed position. Icing conditions should be avoided. If the cowl valve open light remains illuminated bright when the engine anti-ice is turned off, the valve has remained in the open position. If the total air temperature is above 10 degrees Celsius, limit the N1 thrust on the affected engine to 80% if possible. The cowl anti-ice light illuminates if the pressure in the duct leading to the cowl lip is greater than the limits. The master caution and anti-ice system annunciator lights also illuminate. Reset the master caution system. If flight conditions permit, reduce the thrust until the light extinguishes. You control wing anti-ice from the flight deck by a single wing anti-ice switch on the forward overhead panel. The switch has an on and off position. There is no anti-ice protection for the outer slats or the leading edge flaps. The bleed air from the pneumatic manifold goes to most of the leading edge slats. The wing anti-ice valve open lights indicates the position of the wing anti-ice valve. The lights are extinguished when the valves are closed. Now turn on the wing anti-ice. The lights are illuminated bright when the valves are in transit or there is a disagreement between the valve and the switch position. The lights are dim when the valves are open. Let's first look at ground operations. You must use wing anti-ice during all ground operations when icing conditions exist or are expected. Now turn on the wing anti-ice. Make sure the valve open lights illuminate bright, then dim. On the ground, wing anti-ice prevents the formation of frost and ice accumulation on the leading edge slats. Warning: the use of wing anti-ice on the ground is intended to complement and not replace ground de-icing, anti-icing, and inspection procedures. The engine thrust setting and temperature in the wing duct can cause the wing anti-ice valves to open or close. Now advance the thrust levers. Both valves close when the thrust on either engine is more than the takeoff warning setting. Now retard the thrust levers. If thrust is reduced, the valves open. Both valves close if either temperature probe senses an over-temperature inside the wing duct. If both probes sense a cooler temperature, the valves open. The wing anti-ice switch moves to off at liftoff when the air-ground sensor changes to the air mode. In flight, duct temperature and engine thrust setting have no effect on the operation of the wing anti-ice valves. Now let's look at flight operations. There are two methods of operation for the wing anti-ice in flight. The primary method uses the anti-ice system as a de-icer. This method allows the ice to accumulate before you turn on the wing anti-ice. Now turn on the wing anti-ice and look at the wings. This method provides the cleanest airfoil surface and the least runback of ice formation on the wing. It also uses less fuel than the secondary method. The secondary method uses the wing anti-ice system continuously to prevent ice from forming. Use this method only during extended operations, such as holding patterns, in moderate or severe icing conditions. This method creates a possible runback of ice formation and uses more fuel. The wing anti-ice system is turned off when it is no longer necessary. Now turn off the wing anti-ice. Make sure the wing valve open lights extinguish. Caution: do not operate engine or wing anti-ice when the total air temperature is above 10 degrees Celsius. Let's now look at a non-normal condition with the left wing valve. If the left valve open light remains illuminated bright when the wing anti-ice is turned on, the valve has remained in the closed position. Icing conditions should be avoided. If the light remains illuminated bright when the wing anti-ice is turned off, the valve has remained in the open position. Bleed air must be controlled with the isolation valve switch and the engine number 1 bleed switch. You control window heat from the flight deck by window heat switches on the forward overhead panel. The switches have on and off positions. Windows number 1, 2, 3, 4, and 5 are electrically heated. In addition to electric window heat, conditioned air flows across the inside surface of the forward windows for defogging. You pull the windshield air control knobs on the captain and first officer instrument panel to control the flow of air. Window heat is turned on during pre-flight. For purpose of instruction, only the right window heat system is discussed. Now turn on the right forward window heat. The forward window heat switches control heat to the number 1 forward windows through automatic temperature controllers. Next, turn on the right side window heat. The side window heat switches control heat to the number 2 side windows through automatic temperature controllers. The number 3 windows and the number 4 and 5 eyebrow windows through thermal switches. The temperature controllers heat and maintain windows number 1 and 2 at the correct operating temperature. When sensors in windows number 1 and 2 detect a lower temperature, a signal is sent to the controllers. The controllers apply electrical power to heat the windows and the on lights illuminate. The controllers automatically remove electrical power and the on light extinguishes when the correct temperature is reached. All window heat should be on at least 10 minutes before takeoff and should remain on during the flight. This makes sure the windows are at maximum strength in case of a bird impact. The window heat is turned off during shutdown or when the flight ground time is more than 30 minutes. Now turn off the window heat to complete the shutdown. Now let's discuss non-normal conditions. The temperature controllers also monitor windows number 1 and 2 for an overheat condition. If a window overheats, the overheat light, both master caution and anti-ice system annunciator lights illuminate. Reset the master caution system. The temperature controller removes electrical power from the overheated window and the on light extinguishes. Now turn off the heat for the affected window. The overheat light extinguishes and the monitor system is reset. With the window heat system off, the maximum airspeed limit is 250 knots below 10,000 feet altitude. The probe system components that use electrical power to heat are the pitot probes, elevator probes, alpha vane sensors, and the total air temperature probe. The probe heat controls are on the overhead panel. Switch A controls the left system heaters, and switch B controls the right system heaters. The probe heat system is turned on after engine start and turned off during taxi-in. Now turn on the probe heat. Electrical power now heats the left and right probes and sensors. The illumination of a probe heater light shows that its component is not heated. The master caution and anti-ice annunciator lights also illuminate. Reset the master caution system. A blocked or frozen probe system may result in incorrect flight instrument information. You should avoid icing conditions if there is a probe heat failure. The rain removal system for the number 1 windows consists of wipers and a rain repellent coating on the windows. Wipers are used in rain or snow during taxi, takeoff, approach, and landing. Caution: do not operate the windshield wipers on a dry windshield. Operating the wipers on a dry window can damage the permanent rain repellent coating. The windshield wipers selectors on the forward overhead panel supply speed selection and stow the blades. A separate independently controlled system operates each wiper to ensure clear vision through one of the windows if a wiper fails.